Hello, everyone. For folks who don't know me, my name is Priscilla Carmini. I work on the traditional territories of the Neutral, Anishinaabe, Haudenosaunee, Huron-Wendat, the Seneca, and the Mississaugas of the Credit territories. So that's Waterloo and Toronto, respectively. Today, I find myself in Waterloo, Ontario, Canada. So I'm the Digital Repositories Librarian at the University of Waterloo and the chair of the Carl Canadian Repositories Community of Practice Steering Committee. So I welcome you today to our amazing session titled Repositories in the Age of AI, The Attack of the Bots, which is a fantastic title. So thank you for our speakers for coming up with that. And it's my pleasure to introduce you to our wonderful speakers today, Erin Griffith and Rosalind Metz. So Erin Griffith is the program manager for Fedora, an open source digital repository platform dedicated to long-term digital preservation. In this role, she leads community engagement, aligns global user priorities, and serves as a strategic liaison between Fedora governance and its stakeholders. She also facilitates cross-community working groups that foster collaboration and maintain alignment across open source technologies. In addition, Erin is the founding stakeholder of the AI Discussions Working Group, which organizes the monthly Solutions Showcase series, which I will be linking in the chat because it's a great series that folks should take a look at. And then we have Rosalind Metz, who is the Chief Technology Officer at Emory University Libraries and Museum, where she leads a team of 24 professionals and manages a $4.5 million technology budget. She advances open infrastructure, digital preservation, and user-centered discovery, drawing on experience in both higher education and industry, nationally and internationally. Rosalind has held leadership roles in global open source communities, including Fedora, Subvera, and the Oxford Common File Layout Editorial Group. She is a frequent speaker on AI, technology, open infrastructure, and is the author of The Digital Shift, a widely read Substack. A great Substack, by the way. Folks should definitely subscribe. And recently, she was invited to give a keynote at iPres 2025, which is held in New Zealand. So we have a great roster of speakers today. They're fantastic. They have lots of experience in this area. So we're really excited to hear from them. And just a few final notes before we do begin. Just so folks are aware, we will be hosting another event around December 2025, but more events, that event kind of details will be, incoming sooner rather than later. But also, if you're not aware, there is a free scholarly communications channel on Mattermost that allows librarians in Canada to connect to colleagues in similar fields. So if you would like a invite to that Mattermost, please let me know and directly in the chat, and I will send you that invitation. And without further ado, I will pass it off to Erin and Rosalind to begin their presentation. Thank you both so much for being here. We're really excited to hear from you.
Thank you. Thank you for having us. We're very pleased to be here. I'm going to get started. I'm driving the slides today, so I'm hoping everybody can see this. I think we should be good to go. Awesome.
Yes.
Yeah, so that's perfect. So again, my name's Erin Griffith. My normal hat I wear, I'm the Fedora program manager. But today I'm here representing the working group that I kind of co-facilitate with several other stakeholders, the AI Discussions Working Group. And Rosalind and I are here to talk about kind of the impact of bot scraping on, repositories and digital library and cultural heritage infrastructure in general, and kind of the themes and the things that we're seeing as we go through. So Rosalind, if you want to go.
Yes. So I'm going to start with a little bit of an overview on the basics of AI and bots. Right now, the hype cycle really wants you to focus on LLMs, and the people running technology companies want you to focus on LLMs. But just a reminder that LLMs are not AI. AI is lots of different types of models. I have a few here. So algorithms can be considered AI, diffusion models, vision models like OCR, reinforcement learning, and then there are large language models, which is what ChatGPT and Copilot and Anthropic and all that is. But there are also small language models too, which don't take the entire internet and then try to learn from it. Next slide. So a quick, even though I say don't think just about LLMs, one of the things we're here to talk about is the scraping of the internet. And the reason scraping of the internet is happening these days is because most of the large tech companies and most companies in general have chosen to focus on LLMs. LLMs work through something called tokenization. So I have a lovely little diagram here that I've used in the past to describe tokenization. But essentially, when a user inputs a word, what happens is that the LLM will take that word and section it up into pieces. In this example that I'm giving here, it's sectioning it up by word, but just know that not all LLMs section up or tokenize the inputs by words, but can do it by chunks of words. So if you think of something like the word impossible, right? There's the im phrase, there's the pos phrase, and the ibble, and they all have some sort of meaning in the English language about how, like, what those different words do to the word as a whole. But in this example, we'll take it by word because it's just easier to put on a slide. It then takes those words and will turn those words into a numerical encoding. So some sort of number. In this case, I put random numbers that I just typed on a keyboard. But it will chunk it up according to numbers. It will then take those numbers and do some statistical analysis in the background. So if I were to say, hello world to you, you might have things in your head that you automatically think about, right? What your response might be if I'm like, hello world. And that's basically, although I don't like to anthropomorphize AI, that's basically what it's doing. It's doing a statistical analysis of like what, based on all of the things that are in my training model, what is the statistical likelihood that the next set of words will be something? And it's, again, looking at the numbers. It's not looking at words. It does not care about words, technically. And you can see how chunking up a word by its individual parts would be really, really helpful if you're trying to figure out how to respond. So it does its statistical analysis, and then it selects the most probable words that would come out. And if I were me and an AI, my likelihood would be, hi friend, how are you? Or just hi friend. And so it will select the next likely possible set of words or numbers, and then re-encode that as words. And in this case, it says, hi, friends. So that's how tokenization works. And you can imagine that the more data that you have, the more statistically accurate you will be, right? And that is why AI is going out and scraping the entire internet, because it needs a lot of words to figure out the statistical math, but that is being done behind the scenes. When I was in grad school, I had the joy of taking a class on algorithms. And I'm not joking, I really thought it was fun. And we were given an algorithm and we were able to tweak different sections of the algorithm, right? Those different statistical analyses that an algorithm has. And you could see as you ratcheted up one thing, how the results would then change. In something like a large language model, oftentimes companies like ChatGPT or OpenAI or Anthropic, they don't actually know what they're ratcheting up and what they're ratcheting down. It's kind of a guessing game because there are so many variables that they're dealing with. But you can think of it, like the reason ChatGPT becomes so sycophantic is that OpenAI ratcheted up a variable and discovered like, oh, it will be extra nice and complimentary to people if we ratchet up this variable, which is why they then ratcheted that variable up again when people started complaining about ChatGPT 5 not being sycophantic enough. Those are fun articles to read. So the next slide, I'm going to talk a little bit about what are bots. So bots just generally are computer programs that automatically perform tasks online. Some bots are designed to gather information from websites. And bots have existed as long as the internet have existed. This is how Google does its search rankings, right? It has always had bots that go out, look at web pages, scrape the data, and then use that to create an algorithm. So some bots are designed to go out and gather information from websites. Some bots are there to just, I don't know, check to see if a website is up or down. There's all kinds of things that bots can be used for. But in terms of AI and what it's doing is it's actually going out and scraping content from the internet. I can't say for certain this is what every company is doing, but the common crawl, which is how many AI companies start or what many people will use in order to train large language models, uses the web archiving standard that libraries use. In fact, people from the common crawl hang out in Code for Lib if you are part of the Code for Lib community. So it will go out and create, it being the common crawl, will go out and create a WARC file, which is a web archive file. And if you're curious about how WARCs then break up those files, there's lots of information out there. That's the same process, FYI, that the Internet Archive also uses for archiving the internet. Next slide. So when I say that bots will read the page, and actually the WARC, one of the outputs from a WARC file is like a text file of just the content of a page, or just also the HTML, but they're doing this the same way that a user does. One of the things that makes bots, AI bots, a little bit different is they're trying to get down to all of the different permutations of a web page. So when they're going to our catalog, it goes to the catalog and says, okay, now from here, I have found 8 million different links. What it doesn't know about our catalogs, those are facets. They are not links to like new content. They're just facets. So that's one of the things that bots will do is they'll go out and they'll click on the links to try to get even more content that they are then generating. So they'll copy all the text on the page. If they're a bot that is also looking to train on image generation, it will look at the images, it'll look at the links, it looks at the HTML, it looks at the metadata in the header of an HTML. All of that stuff it will take a look at, and it doesn't ask for permission to do any of this. And in fact, 9 times out of 10, it is ignoring the robots.txt file. They see that, I would imagine, I can't say for certain, they see that as something to determine what should be indexed in a search engine, not what they can take for their purposes. We're at peak capitalism here, friends. So scraping can be targeted for specific information. It is possible that you're like just scraping because you want certain type of information, or it could be broad. Like you could just be looking for everything that you can possibly find. But most of these bots are, let me find everything I can possibly find on the internet. Next slide. So LLMs are really pattern matching programs, which we just talked about. Texts are broken into the different tokens. They're assigned numbers mathematically. And they have all of those different settings, sometimes billions of settings, that allow them to predict what is next. What is really helpful, and one of the things to remember is, because this is about statistics, it's about the way the content appears on the page. So if I have the title of the page, all of the content that then appears on the page is even more relevant to what's in that title than, say, content on a completely unrelated page. And this is where I believe one of the reasons that AI companies are very interested in our content is because we have handcrafted metadata. So Erin, if you go to the next slide, we'll talk a little bit about that. We all know why we have created metadata over the years, right? Because we know that the best way for a human to quickly figure out if they want a book is to add all that metadata to a page about that book, right? So that they don't have to go up to the shelf and like flip through the whole page. Like that metadata becomes a really great way for humans to make a decision about whether or not to read that book. It gives us a lot of context, a lot of meaning, all of the things that makes it easier for people to find stuff. At the same time, it also helps large language models train faster and produce more accurate outputs. Because the content that is on that page of a record for a book has been trained by a human and put there by a human expressly to help people figure out how content is related. I will say, like, anecdotally, one of the things that, as I'm having some conversations with Microsoft for an idea that I actually don't know if it really matters anymore, but I was talking about our content that we have, and they said, oh, I bet you have some great metadata. And I was like, yeah, and we've already blocked you from getting it. So but like they were like, oh, it'll be so easy for us to train the LLM because your metadata will be fantastic and perfect. And it was like, yeah, thanks for that. The Microsoft employees don't know what we're talking about right now. But it's just like, I thought it was so ironic that they were saying this to me. So next slide. The other thing to remember too is, like, when you go to things like our open access repositories, those sorts of things, it's even better for them, right? I mean, when I explain this to a layperson, and something I don't have to explain to you, is like, if I wanted to learn everything I could, where would I go? I want to have unlimited access to as many books as I can. Of course, I'm going to go to a library, right? Like, it's going to be expensive not to go to a library. And so I do think that is one of the reasons that they're like, oh, let's go to a library and see. I actually went and looked in the Common Crawl has an index that you can go and look through to see if your website is in the Common Crawl index. And I will find that link and then give it to you. I actually had to mark it in my Zotero library because I kept wanting to go back to it. But Emory's main website is not in the Common Crawl index, but every one of our library applications is. And I do think it's because that is much more useful to users than like users of the Common Crawl than it is than like the university's homepage, which is just a lot of glossy, pretty pictures. The other thing too, a fun fact that one of our fellow AI discussion group members pointed out is there's this really interesting group on Reddit called web scraping. I love to sometimes go and lurk in that group because they are all sitting in there. They are all people who are doing web scraping, and they are trying to find ways to do scraping faster, quicker, cheaper. Like just constantly trying to find a way to do it faster, quicker, cheaper. So I think that is another reason that library content and library websites is helpful, because we've already done all that labor for them. And we can get to the ethics of AI maybe in a discussion, but next slide. So I think, Erin, this is you.
I think that's me, yeah. So we're going to talk really quickly a little bit about kind of the attacks themselves, what they look like, and what, people are kind of experiencing when it happens, right? And it changes all the time, but we know that not all bot attacks look or feel the same way. They, like I said, they're changing all the time. And when an institution experiences an attack, it could look very different day to day, right? It could present with different impacts, and what was happening 6 months ago is not what it's looking like today, right? So, but what we can kind of summarize or put into some common characteristics here, what those attacks kind of look like. So oftentimes it appears as though there are kind of many simultaneous requests hitting a server or a service at one time. And this could be upwards, in the range of millions of requests per day, per minute. We have some examples to show in just a minute here of some real life attack data that people have given us. The requests can come from multiple IP addresses at the same time, often masquerading as what would look like kind of normal users. So they're coming from localized areas, and they're coming from legitimate looking locations and service providers. So it's hard to discern whether, we're looking at a bot or these are legitimate requests. The bots or harvesters are working around those robot.txt restrictions, like Rosalind said. So they're sidestepping the rules that are in place to kind of support and help, this function. And then if you dig in, you would see that the user agent strings don't give any indication that the user agent is a bot. And then the user agent string itself is being changed or modified with each request, so that blocking for user agent becomes nearly impossible, right? They're modifying on the fly, things are happening very rapidly, and they're very kind of sneaky and tricky to get around. And so how is this different than something like a distributed denial of service attack or a DDoS attack? So with a DDoS attack, and there's a picture here as an example, what the bots in this particular example are aiming to do is intentionally hit a system with the goal of taking it down or taking it offline, right? It's malicious and it's intentional. They want to take the service down. And that's different than what these bot scrapers are doing, because these bots don't actually want to take the servers down, because then they can't get what they need from the systems that they're hitting. They're making the request of these things because they want the data that's there. So they're trying to scrape and crawl our catalogs, our repositories, our library systems, to get all the information that's in there. So these types of attacks will sometimes slow down or reduce the volume of requests if they're seeing that the systems themselves are slowing, or that it's, we're getting to timeout situations. They'll pause if the server goes down and then resume once it's back up. And so it doesn't seem as though they're intentionally attempting in any way to compromise the server. So that's what kind of makes them different than something like a DDoS attack. They're also looking to mimic the request that a legitimate user may make, like I said. So that makes it very hard to differentiate between legitimate users and these crawlers, which makes mitigation much more challenging as well, right? You don't know it till you see it happening, and then you're like, this isn't normal. And, kind of that's the situation that I feel like a lot of people are finding themselves in right now. And so then obviously all of these things have impacts, right? The trickle down effect can be felt across anyone and everyone that interacts with the systems. For users they may experience a really wide range of service interruptions, downtime. Sometimes it's denied access, right? We're working with people in our working group who have had to close off public access to systems that were previously accessible. You have to log in by VPN. And so, this restricted access really works against a lot of the things that the libraries and the cultural heritage institutions are working toward. But this is kind of the only thing that we can do. There's downtime, slowness, and all of this in the end, unfortunately, it degrades the reliability of the institution to provide resources to its patrons, right? So if you're continually going to a site and it's down or it's super slow, like, you're not going to go back there. And so this is having detrimental effects on the institutions themselves. And it's not ideal for something like a library or a research repository whose main goal is to provide user access to the data that they have, right? That is what they're there for. But unfortunately, they have no other way around this right now. Other impacts, to the system itself, when it's getting hit with all those requests, it can cause spikes in bandwidth usage, leading to increased server charges, right? So there's a cost, like a physical cost, that comes along with this. And then there's the staff impacts, which, are sometimes not spoken about, right? Staff are faced with this ever-changing list of priorities. They have to put aside normal job functions to go and handle servers down because of these bot attacks, right? And so this added strain and pressure of what is happening can be overwhelming, right? And I think a lot of times we don't talk enough about that, about what's happening to the people who have job functions that are required to keep these systems up and running. They can't do their normal job functions because they're just constantly playing whack-a-mole or needing to retune systems to keep them up. And so keeping them up and running becomes challenging. And so it's not just, one person or one part of the system that is feeling the impacts. It's really widespread and far-reaching.
So I'm going to talk through some case studies. I'll start with my own institution. So what we have seen on our end was sustained high levels of traffic. And you can see from this slide that just before the increase happened, this is our longest sustained attack that we experienced in February as a Valentine's Day gift, I guess. I don't know. Or a present for my daughter's birthday. And it started off at its peak that we were having about 8,000 visits during a similar time scale. And then it rose, you can see at its peak, it was on one day, it was over, because remember, this is actually like their hours between the days. At its peak, it was at around 25,000 hits an hour, we'll say. The impact really does depend on a variety of factors, which Aaron was talking about this, but our biggest issue had been initially the CPU utilization would reach about around 100%, which you can see in the bottom graph. What's interesting is that the CPU utilization may not hit 100% when you're at the peak of the attack. It's actually sometimes after the attack because there's like a lag time almost of, okay, we're trying to process all of the things that are in the queue. And then when it continues to have to process a lot, it will continue to have a really high CPU utilization, which will in turn change all of this to be like, seconds of like 30 seconds of a wait in order to show up a page. Or it could be that the server just seems like it's down. That's the other thing. But usually what we see is like it'll start as slowness. So whenever a user, we have like post-traumatic stress disorder in my team. So now when we see anybody's like, there's slowness, we're like, oh God. So we have these dashboards, which is where I pulled this from, that we use to then show, to see what's going on the server, and all of that. Next slide. So Aaron talked about the sophistication of the attackers and how they will change They will have multiple IP addresses. They will try to evade detection by pretending to use odd browsers. So the user agent, like if you were to go in your browser window and hit a website, what on the website end, there is information about the user agent. So like we can see what type of browser you're using. And, you know, that's really useful for things like what kind of browser should we be supporting? Like, is anybody using Microsoft Edge? I don't know. Things like that, which we usually will get through Google Analytics, but you can also get through server logs as well. They will oftentimes change those user agents. My favorite is when they will have a typo in there. I think one of these has a typo. One of these user agents down here has a typo in it, which is kind of fun. The other that is my favorite is when it's like an Android 6. It has like 78,000 hits. Like, come on, who's using an Android 6 on and trying to like browse the internet? Anyway, it's like those sorts of things that just seem off, and you kind of have to look at the list of user agents. We do it by request account because that will give us some sort of, you know, if it's an Android 6, maybe we can block that user agent. Because if you're on an Android 6, maybe you shouldn't be looking at our website. But anyway, the other thing is the IP address. And here you can see that the IP addresses are 51.22222 or 222.253.1.14.3.2.13.7.4.8, right? Like they're all in a group together. So most likely what this person did is found some cloud hosted environment, provisioned all of these IP addresses all at once to send the bots to start doing their web scraping for them. What's really interesting is we will see people who are doing it on like AT&T. And we have had situations where we will block like an AT&T or, you know, whatever range, and then it comes back to bite us later because we get a bunch of actual humans being like, why can't I get to your catalog? Well, because we had a 4-day bot attack, okay? Just bear with us here. But you can see like something like this, you just at that point you're just like, okay, I'm gonna block a whole range, because that's the fastest way to make this stop and to restore the service. Next slide. So the two things that we've done when our attacks first started, we thought most of it was something that we could solve through CAPTCHA. And we implemented like honeypot CAPTCHA, but that didn't work. We didn't really know what we were dealing with at that point because that was back in like early spring, I want to say. Right now, what we've ended up doing is we've implemented, because all of our stuff is in Amazon, we've implemented an AWS web access firewall. It checks the user agent, it checks the IP address, it determines whether or not it's on our block list or on our allow list, which we also use, how many requests they've made in a certain given time period. Like if you're up to 78,000 requests in like 3 minutes, that's fishy. And if you have too many requests, or it may think you're a bot and then ask you to solve some sort of CAPTCHA. We have had a few users who have been challenged by CAPTCHA and they're not a bot, but I will be honest, it's mostly librarians who are just like doing stuff in the catalog. So that's your problem. I'm like, I mean, sure. I'm not going to tweak it though. We also have talked about automatically adding infrastructure, but we want to try to avoid that because it could we could end up in a situation where we're paying an exorbitant amount of money if we just decide to implement auto scaling. I will say we have scaled up most of our servers to be able to withstand lower level bot attacks, just because it's better for everybody's mental health not to be waking up at 2 a.m. having to try to block a bunch of bots, which is where the manual intervention comes in. Like if the scaling doesn't and the web access firewall don't work, then we'll go in and we'll just start finding all of the IP addresses and just blocking them as much as we can. A couple of other good case studies, next slide, is Princeton University. They provide users access to their collections through a variety of different blacklight tools. I will say you can actually find a lot of information on the internet about how bot attacks are really impacting the open source community, because oftentimes the open source communities membership are running their own servers, and large corporations will just sort of absorb the cost and pass it on to their customers. And that may be one of the reasons that like prices are going up, and you just don't know that those prices are going up for those reasons. What Princeton did was they actually implemented Cloudflare turnstiles. And you can see here that at one point, 63% of their requests to their catalog were actually identified and filtered as bots. And today on the internet, over 50% of web traffic is actually bot traffic. It's not humans anymore. What's nice about Cloudflare turnstiles is they do it for you. And they will verify people versus bots using Cloudflare's technology. I will also say at one point, Princeton was considering hiring somebody focused on security. And actually, for myself, we had one person who recently went to AWS, like one of their conferences, I forget which one. And all he did was focus on the security stuff because that's where we needed the most support. The Explorers Chicago collections is another example. They actually put Cloudflare, not Cloudflare turnstiles, which is just a different product, but they put Cloudflare in front of the Explore Chicago collections, which is a group of institutions in the Chicago area that talk about Chicago stuff. Their repository has been overwhelmed by bots. They do not have any technology folks assigned to like work for the Explore Chicago repository. So they put Cloudflare in front of their repository, and it's basically closed off now. You can't really get to it. I mean, if you Google it, you're welcome to Google it, and you'll see like it challenges you all the time. So that ends up being like a barrier, especially when you're thinking about small collections and how they deal with issues that, you know, even Princeton or Emory are struggling to deal with too. Next slide. UNC Chapel Hill actually has a lovely story, which is in our resources list. UNC Chapel Hill had an issue the week of finals, because that's how this tends to go. I will say that we had that February one. I think we had like midterms during that period because, you know, why not? Anyway, during finals, they were seeing like way more access than what they were used to seeing. When they actually, my favorite quote is somebody I went to grad school with. His name is Jason Kasdan. In that article, he's like, I opened up my console and it was like a hacker video, and it was like scrolling by, and I was like, that sounds so cool. I've always wanted it. Didn't sound cool, but like it sounds cool. They did do some filtering at first, and that worked briefly, but then everything just came back in even harder force. And they're pretty sure that it is an LLM. One thing that you can do is you can actually look at the IP addresses, like Alibaba hits our stuff all the time. I've caught Microsoft Copilot hitting our stuff. Like they're it's all of the companies are contributing to this, and I just find it very funny. But you're essentially in an arms race when you're in one of these things, which is something else that they said, and I really appreciate. I will say this isn't just happening to libraries, and I have a couple of examples of other people that this is happening to. Read the Docs, which is a free open source documentation website. They get all of their infrastructure from AWS, and in a single day, a bot came along and pulled down 73 terabytes worth of documentation, which used up all of their infrastructure funding in a month or something like that. So $5,000 in bandwidth charges, which they never would have had an experience of. They were able to identify who it was that was doing that crawling and downloading all that data. And then they went to them and said, you owe us $5,000. And they paid because it's an open source project. And that's kind of, yeah, hopefully it was another technologist who was like, oops, sorry. But yeah, I will say one of the things that Read the Docs has done is they've actually implemented a content delivery network, which is an intermediary that caches the files that people are pulling down. But if we go to the next slide, what we learned from Wikipedia's experience is that caching doesn't always solve the problem. So Wikipedia has had similar experiences around AI that libraries have. And if they're complaining about it, none of us in libraries should feel bad about it. But they often get bots overwhelming their infrastructure because Wikipedia is a really great place to learn things. They are doing a lot around trying to improve detection of bots, throttling bots. And they have new policies that they've put in place to balance their open access with more sustainable, ethical use of their infrastructure and their data, right? Because it is a cost issue. It is not just that's really shitty for your employees. Like it is like that's a big bill that you can get. One of the things that Wikimedia is doing is actually looking into setting up an entirely separate infrastructure from the like public AI or their public interface, so that they can actually prioritize human beings over the bots. And that's their explicit goal, prioritize the humans over the bots. I have links here for both their policies and their strategic objectives that they're using to try to increase the infrastructure. The last thing I will say that's interesting is that Google Scholar is struggling to index our repositories because we're blocking them. So this is like an anti-case study. Some of that I don't feel bad about because they don't really have good documentation. And also Google does not disambiguate between its different bots that it has. So you don't know whether or not you're being crawled by Google Scholar, Google Search, Google AI, you don't know any of that.
So then, like, what now? This is all sounds very kind of like apocalyptic, and what are we going to do? But unfortunately, we don't have like a full answer. But why does it matter specifically, though? Like, you know, the bots are attacking. Obviously, the LLMs are training. Why don't we just let them? But this comes down to you know, many things. But you know, we discussed previously that institutions are running up against this increasingly challenging workload and this continual need to keep the servers up and running under the pressures of continued bot scraping. So, how do we, we're struggling just to keep up, let alone make a plan or have a path forward toward resolution, right? So we need to come up with some sort of solution that is going to get us to a place of not having to continually play whack-a-mole, which is where we kind of stand right now. And then one of the other things that we, especially in the libraries and collections world, and Rosalind talked a little bit about this before, but we, these bots and these models are scraping content at face value. So we have highly curated collections that are built and crafted by human individuals trying to tell a story. We've put them together very intentionally. We've given them context and meaning, and then the LLMs are just taking this data, scraping it at face value, and all of the context and nuances are lost, right? So our work becomes lost, and the importance of data curation becomes less valued. And some of this information, be it sensitive topics or things that are put in place for very particular reasons, that gets all lost when an LLM scrapes it, right? And so we're not able to protect the value of that data or protect the original content as it was intended to be delivered. And then the last thing, we see people turning less and less to the traditional library for information. They're not going to the physical spaces anymore. Why would you? When you can just sit home and ask ChatGPT. That was like a little loop of somebody sitting and prompting GPT with information from the Emory collection. So like patronage to traditional libraries is waning and people aren't going anymore. So what does that mean for our physical institutions that, want to maintain this space for people to come and learn? And then how do we stop it? We've talked about some different technical solutions. I would encourage you to come out to the solutions showcases that the working group that I work with facilitates. There's some ideas listed here and there's pros and cons to all of them, but many institutions have had to implement several of these in conjunction with each other, in combination, just to keep their systems up. And the longer that this continues to happen, those bots are becoming smarter. They are figuring out how to get around these things. And it's this constant need of upkeep and tuning, and resource-wise, it's expensive to do, right? Both time and people and cost. It can become extremely prohibitive in some instances for institutions to even implement these things. So it becomes this very impossible challenge to overcome. And then the other part of this is the policy and advocacy side. Again, I don't have an answer to this, but institutions keep getting faced with this double-sided problem of needing to have data and content that's open and accessible. But how can they, and really should they, remain open and accessible to everyone if we're under this constant threat of being attacked and having our servers at risk all the time and users can't get at them? So it's we're open, yes, and we want to be open, but is it open to only humans? Is it open to everyone? Do we truly mean everybody? Is it humans, bots, and the web crawlers? And then how do we balance that, right? There's just this cost associated with what's happening in this ecosystem right now that it feels unsustainable at this moment, right? Mitigation tools supplied by vendors are expensive, in-house strategies are resource intensive and time consuming. So it's a conversation that our working group, and I'm sure many of you have been having, about how we can, as libraries and cultural heritage organizations, protect ourselves while continuing to operate for our patrons. So I know we are running up against, the end of our time here, and I want to save space for questions or conversation, but this is the AI discussions group that I keep mentioning. We kind of call ourselves a ragtag group of individuals. We represent a lot of on the ground technologists, sysadmins, middle level managers who are seeing the direct impacts of these things happening on a day-to-day basis. And we're just there to kind of support one another and offer a place to collaborate on solutions. The Solutions Showcase was another thing that I mentioned. That is a free virtual session that occurs monthly where people come and discuss their implementations and do a live demo. There's space for questions. And then, we have the recordings available to those who request it. But, we don't just represent repositories. We represent people from across the GLAM sector, really just kind of coming together to do something about it, kind of in the immediate, in the right now. So these are our goals. This is some work on our showcases. And I believe I saw somebody post a link to the showcases in the chat, so thank you for that. And that is our resources. But again, we're going to provide the slides to Priscilla and the team at Carl so that you guys can have them and have access to that information. But I think we'll stop there.